Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. When people think of AWS costs, they often focus on compute and storage EC2 instance hours, RDS databases, or gigabytes in S3. Yet one of the most overlooked drivers of spend is data transfer. Every byte that moves across boundaries has the potential to add to your bill, and these charges are often invisible until they show up on a detailed invoice. The main distinction to remember is that moving data into AWS is almost always free. But moving data out, whether to the internet, another region, or even between availability zones, carries a cost. Understanding these patterns is essential not only for cost control, but also for designing architectures that avoid hidden inefficiencies. On the exam, any mention of egress or cross-region should immediately signal potential cost implications. Inbound versus outbound is the first principle. Inbound data, meaning traffic flowing into AWS from the internet or external systems, generally costs nothing. This encourages customers to bring workloads and data into the cloud without penalty. Outbound data, however, is charged. Whether it's sending files to users over the internet or replicating objects to another region, egress carries fees. This asymmetry is important. It shapes how AWS architectures are designed, and it explains why services like CloudFront and Direct Connect exist to optimize outbound paths. For the exam, data in is free, data out is charged, is a foundational rule to recall. Internet egress is charged by region and follows tiered pricing per gigabyte. For example, the first several gigabytes may be free or at a lower rate, but higher volumes cost progressively less per gigabyte. The exam won't expect you to memorize numbers, but will test your awareness that internet egress is never free and that rates vary by volume and region. In practical terms, this means that a video streaming service delivering content directly from an EC2 instance in a region could rack up massive egress bills. The architectural signal is clear: minimize raw internet egress wherever possible by using caching or edge services. Cross-region transfer is another hidden cost area. If you replicate S3 buckets across regions for disaster recovery or run cross-region database APIs, you pay for the transfer. This is often overlooked in multi-region architectures, where teams assume redundancy only costs extra storage. In reality, every replicated byte has a price. The exam may describe replication to another region or cross-region API calls as part of the scenario, and the correct answer is to identify the added transfer cost. Awareness of these charges encourages careful evaluation of whether multi-region redundancy is necessary or whether multi-AZ within a single region suffices. Traffic between availability zones is also billed. Although AZs are connected with high-speed private links, AWS charges for data that crosses those boundaries. This surprises many learners who assume intra-region communication is free. Designing architectures without considering this can inflate bills. For instance, if application servers in one AZ constantly talk to databases in another, costs accumulate. The exam cues here are cross-AZ communication or replication between AZs. The best practice is to keep traffic local within an AZ when possible and replicate only when high availability demands it. This is where cost and resilience trade-offs intersect. Within the same availability zone, transfers are often free, but exceptions exist. Some services charge for traffic even when resources reside side by side. For example, certain load balancer paths may count bytes processed as billable, regardless of AZ placement. The lesson is that same AZ paths can't always be assumed to be zero cost. On the exam, watch for phrasing like same AZ but still charged. The safe mental model is that same AZ transfers are cheaper than cross-AZ or cross-region, but service-specific exceptions must be noted. This reinforces the broader message. Pricing depends not just on distance, but also on the service delivering the traffic. NAT gateways are another cost hotspot. They charge per gigabyte processed, as well as an hourly fee, making them more expensive than many expect. If a fleet of instances in private subnets routes all their internet traffic through a single NAT gateway, costs can escalate quickly. For the exam, cues like private subnet with outbound internet traffic point to NAT gateway charges. The best practice is to minimize unnecessary NAT use, split NAT gateways by AZ for redundancy, and consider alternatives like VPC endpoints for accessing AWS services without crossing the internet. NAT costs are a reminder that design choices ripple directly into billing. Load balancers, particularly application load balancers, ALBs, and network load balancers, NLBs, measure usage not only by hours, but also by load balancer capacity units, or LCUs. One of the LCU dimensions is data processed, which means that bytes flowing through the balancer contribute to cost. The exam won't ask you to calculate LCUs, but it will test your awareness that load balancers add transfer costs beyond the EC2 instances they serve. The takeaway is that every gigabyte flowing through a load balancer has an associated cost, even if the instances sit in the same region. This is another example of hidden charges that accumulate silently. CloudFront helps mitigate these costs by caching content closer to users. When data is delivered from the CloudFront edge, it often costs less per gigabyte than delivering directly from an EC2 instance in a region. Moreover, cached data reduces origin egress altogether. For example, a global news site serving images directly from a region will face high egress bills, while serving via CloudFront offloads both traffic and cost. Exam cues include reduce internet egress or deliver content globally at lower cost. The answer is almost always CloudFront. It's not just a performance tool, it's also a cost control lever. Private Link introduces another dimension, where both provider and consumer of a private endpoint bear some cost for data processing. This is important for SaaS scenarios, where a provider exposes a service privately to customers. Both sides must account for the data movement. Exam questions may highlight this with consumer-provider private connectivity. The point to remember is that Private Link improves security and isolation but still carries processing fees. It's a reminder that private does not equal free. Understanding this distinction ensures you design with both compliance and financial efficiency in mind. S3 charges can also be subtle. While storing data has a clear per gigabyte price, accessing that data involves request charges, and moving it out involves transfer charges. At scale, millions of GET requests or large retrievals from Glacier can add up. Exam cues like frequent small requests point to request costs, while archival retrieval points to transfer and retrieval fees. The lesson is that storage costs are multidimensional. Capacity, requests, and transfers all matter. Smart design involves matching storage classes and access patterns to minimize unnecessary spend. Hybrid links such as VPN and Direct Connect also involve transfer costs. VPN tunnels send traffic over the internet and charge egress accordingly. Direct Connect offers more predictable costs, but still charges for outbound transfer. The exam may describe hybrid architecture with data flowing on-premises to AWS. The correct answer is to recognize the egress charges in play. This highlights the broader principle that data moving out of AWS, even privately, is never free. Hybrid designs must account for both networking architecture and the financial implications of traffic volume. The final best practice is monitoring. Cost Explorer and the Cost and AMP Usage Report (NAR) allow you to pinpoint data transfer hotspots. They reveal which services, regions, or accounts are generating the most egress. Exam cues like identify source of high data transfer costs point directly to CUR or Cost Explorer. In practice, these tools allow organizations to address inefficiencies, such as excessive cross-AZ chatter or replication jobs gone wild. Monitoring is the first step in controlling hidden costs, just as it is with compute or storage. Without visibility, optimization is impossible. From an exam standpoint, the key cues are cross-region, cross-AZ, internet egress, and private endpoints. These phrases almost always signal cost implications. By recognizing them quickly, you can evaluate architectures not only for resilience or performance, but also for financial efficiency. Remember, bytes are budget items, and every path they take matters. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. When you think about AWS bills, you probably picture servers and storage, the hours that EC2 instances run, the gigabytes you put into S3. But there is a hidden piece that often surprises people. That piece is data transfer. Every time data moves across a boundary, costs can appear. The rule is simple. Data that comes into AWS is usually free. Data that leaves AWS almost always costs money. That includes data sent to the internet, data sent between regions, or even data that crosses availability zones. These hidden charges can be large. On the exam, if you see the words egress or cross-region, that should trigger you to think about cost. The first distinction is inbound versus outbound traffic. Inbound means data entering AWS from the internet or from on-premises. Outbound means data leaving AWS. Inbound is usually zero cost. Outbound is where the charges apply. Sending files to customers, replicating databases across regions, or delivering video streams. These all cost money. This is why many architectures are designed to reduce outbound traffic. AWS wants to make it easy to move data in, but it charges when data goes out. For exam scenarios, remember this phrase: data in is free, data out is charged. Internet egress is one of the biggest costs. Egress means traffic leaving AWS to reach the public internet. The cost is measured per gigabyte and varies by region. Pricing uses tiers. The first amount may cost more per gigabyte. Larger amounts may cost less per gigabyte. You do not need to memorize the numbers. What you do need to know is that internet egress is never free. A video app serving streams directly from an EC2 instance can rack up huge egress charges. The smart design is to minimize raw internet egress and offload it with caching or edge delivery. Cross-region transfer is another place where costs add up. Imagine replicating an S3 bucket from Virginia to Oregon, or syncing databases between Europe and Asia. Every byte that crosses regions is billed. Many teams forget this and only plan for the extra storage. They miss the transfer cost. On the exam, if a scenario mentions cross-region replication or cross-region APIs, the hidden answer is transfer charges. This makes you think carefully. Do you really need multi-region, or would multi-AZ inside one region be enough? Cost awareness is about asking that question first. Transfers between availability zones are not free either. This surprises many people. They think that traffic inside a region must be free. But when data moves from one AZ to another, AWS charges for it. The path is private and fast, but it is still billable. If your application servers in one AZ talk constantly to a database in another, the costs stack up. The exam may use the words cross-AZ communication or replication between AZs. Those words mean added cost. The best practice is to keep data local in one AZ when possible and replicate only when needed for high availability. Transfers inside a single AZ are usually free, but there are exceptions. Some services count and build data even inside one AZ. Load balancers, for example, charge for the data they process. That means traffic from an ALB to an EC2 instance in the same AZ still carries a cost. The rule is, same AZ is cheaper than cross-AZ or cross-region, but not always zero. On the exam, if the question says same AZ but still charged, the clue is service-specific exceptions. Always check how the service defines its pricing. NAT gateways are a common hotspot for hidden costs. A NAT gateway allows private subnets to talk to the internet. The problem is that NAT charges twice. It charges by the hour to exist, and it charges by the gigabyte processed. If hundreds of instances route through one NAT, the bill can spike. On the exam, if you see private subnets with outbound internet traffic, think NAT costs. The best design is to reduce NAT usage. Place a NAT gateway in each AZ and use VPC endpoints to avoid the internet where possible. NATs are convenient but expensive if used carelessly. VPC interface endpoints also cost money. They allow private access to AWS services like S3 or DynamoDB without using the public internet. They improve security, but they charge both per hour and per gigabyte. Gateway endpoints are different. Gateway endpoints, such as those for S3, usually carry no hourly cost. They are more efficient for heavy traffic. On the exam, if a question asks how to minimize cost while keeping traffic private, the better answer is often a gateway endpoint. The nuance is important. Not all endpoints are priced the same. Load balancers also count data. Application load balancers and network load balancers measure usage in load balancer capacity units, or LCUs. One part of that unit is bytes processed. That means the more traffic you send through a load balancer, the higher the cost. Even if the instances and load balancer are in the same AZ, the traffic is not free. The exam will not ask you to calculate LCUs, but it may ask if data processed by load balancers adds cost. The answer is yes. Every byte has a price tag. CloudFront helps reduce these costs. By caching content close to users, CloudFront offloads traffic from your origin. Content served from the edge costs less per gigabyte than content streamed directly from a region. More importantly, fewer bytes leave your origin at all. For a global audience, this saves both performance and money. On the exam, when you see reduce egress or global delivery at lower cost, the right answer is CloudFront. Remember, CloudFront is not just about speed, it is also about cutting bills. Private Link adds another twist. It lets a provider expose a service privately to customers. Both sides, provider and consumer, pay for data processing. That means Private Link improves security but still adds charges. The exam may describe this as consumer-provider private connection. The correct answer is that Private Link adds cost per gigabyte. Private does not mean free, it means secure, isolated, and billable. This is a classic example of where security and cost must be weighed together. S3 costs are not just storage, they also include requests and transfers. Every GET, PUT, and LIST call has a small price. At scale, millions of requests add up. Glacier retrievals add transfer charges. For the exam, frequent small requests means request costs. Archive retrieval means transfer costs. The big lesson is that storage costs are layered: volume, requests, and transfers. Smart design uses lifecycle policies, caching, and access control to balance these dimensions. Hybrid links also have egress charges. VPN tunnels run over the internet, so outbound data is billed. Direct Connect provides private paths, but outbound data is still charged. The difference is that Direct Connect has predictable rates. Exam scenarios like hybrid architecture with traffic to on-premises should trigger your awareness. Egress is still billable. Hybrid designs are about more than connectivity. They are about calculating and controlling the ongoing cost of that connection. The last piece is monitoring. Cost Explorer and the Cost and Usage Report, or CUR, show where transfer costs come from. They reveal hotspots like heavy cross-AZ chatter or runaway replication jobs. On the exam, if the question says, identify source of high data transfer costs, the answer is CUR or Cost Explorer. Without visibility, costs stay hidden. With these tools, you can pinpoint and fix inefficiencies. Monitoring is the foundation of all cost management. For exam purposes, remember these cues: cross-region, cross-AZ, internet egress, and private endpoints all mean extra costs. If you hear those words, think about data transfer pricing. In AWS, every byte has a cost path. Knowing that helps you design smarter and avoid surprises. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. The best way to control data transfer costs is to design systems that minimize egress. The golden rule is keep compute close to the data. If your data is in S3 in one region, try to process it there instead of pulling it across regions. If your database is in one availability zone, place your application servers in the same zone when possible. Every unnecessary hop adds cost. On the exam, look for phrases like minimize egress or reduce cross-region traffic. The right answer will always be to move compute toward the data, not the other way around. Private paths are your next line of defense. Use VPC endpoints or private link where possible to keep traffic inside AWS's private network. A gateway endpoint for S3 or DynamoDB avoids both internet charges and NAT gateway fees. Interface endpoints do carry hourly and per gigabyte charges, but they still prevent internet egress. On the exam, when you see keep traffic private or reduce data transfer to internet, the answer is almost always an endpoint. The principle is clear. If you can stay private, you will save money and improve security at the same time. CloudFront is another essential tool. By caching content at the edge, CloudFront cuts down the number of bytes leaving your region. A user in Asia retrieving a file from a US region incurs egress charges if served directly. If the file is cached at a CloudFront edge location, the cost is lower and performance is better. On the exam, if the scenario mentions global delivery or reduce origin load, the right choice is CloudFront. Think of it as both a performance and a cost lever. Fewer bytes travel the expensive path back to your region. Designing architectures with zone awareness also helps. When workloads talk across availability zones, unnecessarily costs rise. For example, two application tiers constantly chatting between AZs may double traffic costs. The better design is to localize communication within an AZ and only replicate across zones when required for high availability. The exam cues here are reduce cross-AZ chatter or zone-aware architecture. The correct answer is to align services by zone, cutting down the background traffic that drives hidden charges. NAT gateways are often necessary, but they should be used carefully. One best practice is to deploy a NAT gateway per availability zone rather than routing all traffic through a single one. This avoids cross-AZ paths that add cost. Another is to avoid hairpinning, where traffic unnecessarily exits and re-enters through the NAT. The exam may ask about reducing NAT gateway costs. The right answers involve per-as placement, use of endpoints instead of internet routes, and careful architecture. NAT is powerful, but without planning, it can become a silent drain on budgets. Data lifecycle decisions also affect transfer cost. Keeping data near the consumers who use it most can reduce movement. For example, archiving logs in the same region where they are analyzed prevents cross-region transfers. Replicating across regions should be reserved for disaster recovery or specific compliance needs. On the exam, phrases like minimize transfer or reduce data movement point to lifecycle strategies. Store data where it will be processed and avoid shuffling it unnecessarily. The rule is simple. Bytes should not travel farther than they need to. Batch processing versus streaming is another trade-off. Batch jobs allow you to collect data and move it in larger, less frequent transfers, often reducing chatter. Streaming, while powerful, creates constant traffic between services. The exam may describe a scenario with high-frequency chatter and ask for a cost reduction. The answer is often batching data instead of streaming. unless real-time processing is required. This highlights a theme. Cost efficiency is not just about technology, but about patterns of movement. Less chatter equals fewer charges. Compression and columnar formats also play a role. When you shrink data, you reduce the bytes transferred. Formats like Parquet or ORC for analytics workloads can cut transfer costs significantly compared to raw CSV files. On the exam, the clue might be optimize analytics costs for large queries. The right answer is to use compressed columnar formats. This is one of the easiest ways to reduce both storage and transfer costs. It is a reminder that architecture includes how you format and move data, not just where you store it. Multi-region designs should be used only when truly needed. Spreading data everywhere may sound resilient, but every replication comes with a price. Disaster recovery and compliance are good reasons. Latency-sensitive workloads with users worldwide may also justify it. But if neither applies, multi-AZ within one region is cheaper and still highly available. On the exam, if the scenario describes minimize cost and no strict compliance, multi-AZ is the right answer. Reserve multi-region for when requirements demand it, not as a default. Testing with synthetic loads can reveal transfer costs before they surprise you. By simulating traffic patterns, you can measure how much data moves and where charges occur. For the exam, this may appear as understand transfer costs before scaling. The best answer is to use synthetic testing in tools like the pricing calculator. In practice, this is how organizations catch hidden expenses early. Testing is not only for performance, it is also for financial predictability. Tagging transfers and attributing them to owners creates accountability. If one team's architecture drives heavy cross-AZ traffic, tagging helps surface responsibility. On the exam, if you see allocate transfer costs to teams, the answer is tagging. Without attribution, transfer costs are just noise on a bill. With tagging, they become visible and actionable. This practice supports showback and chargeback models, where costs are tied directly to usage. Alerts are another proactive measure. By using budgets tied to data transfer dimensions, you can be notified when traffic exceeds expected levels. On the exam, this appears as alert on egress charges. The right answer is AWS budgets. Alerts prevent surprises and allow quick investigation into unexpected patterns. Combined with Cost Explorer or CUR, they form the governance loop for transfer pricing: monitor, alert, investigate, fix. Quarterly reviews add discipline to this loop. By mapping routes and comparing transfer costs over time, you can catch architectural drift. A new replication job or a misconfigured service might quietly add costs. Regular reviews identify and correct these issues. The exam may phrase this as ongoing governance of transfer costs. The correct answer is scheduled reviews with cost tools. This reflects AWS's broader theme. Cloud cost management is iterative, not one-time. A major pitfall is hidden cross-AZ traffic caused by service defaults. For example, some load balancers may spread traffic across AZs unless configured otherwise, creating charges you didn't expect. Similarly, RDS replicas in different AZs generate ongoing cross-AZ transfers. On the exam, if a scenario asks why costs are unexpectedly high, look for hidden cross-AZ traffic. The fix is to design with awareness of defaults and adjust placement. Hidden costs are usually about what you don't see until it is too late. From an exam standpoint, the meta lesson is that bytes are budget items. The further they travel, the more they cost. Local and private paths are cheaper than cross-AZ or cross-region. Internet egress is the most expensive of all. When evaluating architectures, ask yourself, where are the bytes flowing and who is paying for them? That is the mindset that leads to both correct exam answers and smart real-world designs. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.